Okay, everyone, so we'll start today with operating with vectors, and the very first one will be the trig review. The first thing that we will see in terms of the operating with vectors. So now, when we are dealing with trig, what we are doing is we are working in a triangle. The easiest triangle, or the triangle that we will use the most, is the right angle triangle. A right angle triangle is a triangle that has one of the angles as 90 degrees. I have the tendency to write it like this. Then the other thing that we have to keep in mind when we are working with the right triangle is labeling the sides of the right triangle. So if we see here, the triangle has three vertices, vertices 1, vertices 2, and vertices 3, and it has three sides. And actually, the definition of the triangle is a 2D shape that has three sides. And this is a specific case when one of the angles is a right angle. Now, when we are labeling, let's say if we are labeling A, B, C, then when we are labeling the sides will be with a lowercase of the opposite vertices. So on this case, the opposite of vertices A is the side BC. So this is with a lowercase a. And the opposite side of vertices B is the side AC, which is known with, or labeled with letter B. And the opposite side of vertices C, the 90 degree, is side C, is labeled with side C. The first formula that we will use when we are solving a right angle triangle is a squared plus b squared is equal to c squared, which is known as the Pythagorean theorem. So now what this is saying is the length of a to the power of 2 added to the length of b to the power of 2 is equal to the hypotenuse to the power of 2. We all know how to solve this. I'm not staying on this for a long time because as a variation of Pythagorean, what we will have is b squared is equal to c squared minus a squared, or a squared is equal to c squared minus b squared. What we will focus today is when using those that are known as the trig ratio. So if we have a right angle triangle, A, B, C, and on this case, let's suppose that what we have here is that AC is 15 and BC is 20. Then what we are looking for is to find what is the angle theta A. So now in order to solve for this, what we will do is we will use those that are known as the trig ratios. Trig ratios are three. It's sine, cosine, and tangent. Sine is calculated as opposite over hypotenuse, and cosine is calculated as adjacent over hypotenuse, versus tangent is calculated as opposite over adjacent. So now what is opposite, what is adjacent, and what is the hypotenuse? Let's start with the one that is the easiest one, and you probably all know. The side that is opposite to the 90 degrees is known as the hypotenuse of the right angle triangle. The hypotenuse doesn't change no matter what is the triangle. The hypotenuse will always be hypotenuse, while opposite and adjacent depend on which angle you are looking at. What does that mean? If we have a right angle triangle that is A, B, C like this, if I am standing at angle A, then opposite of angle A will be BC. And the adjacent of angle A will be the length of AC, while the hypotenuse is always the hypotenuse. However, if we stand at angle B, then what we will have is that opposite of angle B is AC, and adjacent of angle B will be BC. As you see it here, depend on where we are standing. If we are standing at angle A, then opposite will be the adjacent of angle B, and adjacent will be the opposite of angle B. And this is what I mean when I said that the opposite and adjacent switch sides depends on which angle you are standing at, versus hypotenuse is always hypotenuse. Now, when we are looking to solve for the angle, what we will do is we will use one of the ratios, either sine, cosine, or tangent. And which one are we choosing? We will base it on the information that is given to our triangle. So now we are looking for angle theta, this angle A here. So on this case, what do we have is that the 20 is the opposite of angle theta. And what is given here is the 15, which actually is the adjacent of angle theta. And then the question that we ask is, what is that trig ratio that relates opposite and adjacent? And we will look at, is it sine, is it cosine, or is it tangent? And the answer here will be tangent. So tangent, you can say, of angle A or tangent of angle theta is equal to opposite over adjacent. And the opposite of angle A or angle theta is 20, and the adjacent of angle theta is 15. So now this is a simple math question, so in which we have tangent A or tangent theta is equal to 20 over 15. The way that we solve for angle A or angle theta is by going to your calculator and solving for the angle. So inverse tangent of 20 over 50. So in your calculator, 53.1 degrees. Now, if we are trying to solve the triangle, when you see the expression solve the triangle, what does this mean? Is finding all the angles and finding all the sides of the right angle triangle. So if we are trying to solve the triangle now, not just what is angle A, what we will do is we'll find first angle B, and angle B will be the sum of inside angles. The sum of inside angles in a triangle is equal to 180 degrees. So in this case, what did you have for angle A is 53.1 plus angle B plus 90 degrees is equal to 180 degrees. From here, we find that angle B is equal to whatever the calculator is giving you, will be 36.9 degrees. And if you are looking for the side AB, you can use a square plus b square is equal to c square. So in this case, what we will have is 20 to the power of 2 plus 15 to the power of 2 is equal to c to the power of 2. So in your calculator, you go 20 to the power of 2 plus 15 to the power of 2, the whole thing square root, and c will be equals to 25. Keep in mind that the hypotenuse is the longest side of the right angle triangle. Do you have any questions? Now let's see a side when we have a right angle triangle that we are looking for the side. The angle is given and we are looking for the side. And in this case, the triangle will be PQR, and the hypotenuse is 13, and one of the sides, no, and the angle here is 23 degrees. So we are looking on solving the right angle triangle, finding all the angles and finding all the sides of the right angle triangle. So now the angle that is given is angle P. Let's start with labeling the sides. So in the relation to the given angle 23, the length of RQ is the opposite. The hypotenuse is always opposite to the 90 degrees. And then what do we have is the adjacent is the length of PR. However, if we are looking for the opposite here, then the trig ratio that we will use will be identified based on this that is known as SOHCAHTOA. Okay, what we said before. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. So now on this case, what we are looking for is the opposite, and what is given is the hypotenuse. So then which trig ratios are we using? 1, 2, or 3 is based on the information that we have. So opposite and hypotenuse, the relation is at sine. So that means that sine 23 degrees is equal to opposite that we don't know over hypotenuse, which is given. So in this case, the opposite is an x. We don't know. Something that we don't know, we assign it with x over 13. Now this is turned out to be a simple math. So when we have sine 23 is equal to x over 13, the way that we solve it is by multiplying both sides by 13 so that we can cancel the denominator, and then x will be equal to 13 times sine 23. One thing that you have to keep in mind when you are working on physics is to have the mode of your calculator on degrees, especially for people that are working, that are taking math at the same time that are taking physics. It is very important because math sometimes work with radian and sometimes work with degrees. Physics works always with degrees, especially for what we are doing here. So by typing in your calculator 13 times sine 23, you will have x, or the opposite, as 5.08. And now, how can we solve for the other angle? Angle Q will be equals to 180 minus 90 minus 23 degrees. So in your calculator, you will have angle Q as 67 degrees, angle Q. And if you are looking for the side PR, so PR squared will be equals to PQ squared minus RQ squared, or PR squared will be 13 squared minus 5.08 squared. And again, in your calculator, you square root the answer, and you will have 13 squared minus 5.0308 squared, square root the answer. You will have PR as equal to 11.97. Because now we'll move to that is known as the sine law. Okay, so when we have a right angle triangle, it's fine. We can use sine, cosine, tangent ratio, and a squared plus b squared is equal to c squared. But the question will be, what is happening when we do not have a right angle triangle? And on this case, what we will use is that is known as the sine law and cosine law. So if we have a triangle that is not a right angle triangle, then let's label it as ABC, the vertices of this triangle, and the sides will follow the same pattern or the same rule as we said before. The opposite of the vertex is with the lowercase of the vertex. The opposite of B will be AC, lowercase of b. The opposite of C will be AB, lowercase of c. Now, the sine law states that sine of angle A over length of opposite side A is equal to sine of angle B over length of side B, and sine of angle C is equal to the length of side C. Sometimes you see it like this, sometimes you see it as A over sine A is equal to B over sine B is equal to C over sine C. You have this formula in the formula sheet, so you don't have to remember this, but you need to know how to apply this law. Now, let's suppose that on this triangle, we have a side given as, or sorry, an angle given as, what should I say here, 65 degrees, and a side A as 12 meters. So now we are solving the triangle, and this is, remember, this is not a right angle triangle. We will solve the triangle based on the information that we have. So another thing is that B will be, let's say, 25 meters. So this will be as a given in your question. Now, the sine law is saying sine over A, sine A over A, sine B over B, sine C over C. You will use the ratio that it fits you what the problem is giving. So in this case, if we are looking for angle A, we will use sine B over B is equal to sine A over A. So we will use those first two ratios. So we don't have to use all three ratios. So in this case, what we will have will be sine B over B is equal to sine A over A. And what is given here is the angle B, so this will be sine 65 degrees over B, that is 25 meters, is equal to sine A, which we don't know, over length of A, that is 12 meters. So if we solve now for sine A, see the units will cancel and will work perfectly. So we'll have 12 meters times sine of 65 degrees over 25 meters. So meters and meters will cancel out. And then using your calculator, you will find that sine A is equal. Sine A will be 0.435 and so on, whatever the calculator is giving you. And then the angle A will be the inverse sine of the answer. So in your calculator, you will go second function sine the answer. And the angle A will be 25.8 degrees. So now we have the angle A as 25.8 degrees. Okay, questions on this? Okay, now how do you solve for angle C? Then you go, the sum of inside angles in a triangle is equal to the 180. So you can find that angle A plus angle B plus angle C is equal to 180 degrees. So that means that 25.8 plus 65 plus angle C is equal to 180. And from here, angle C will be, so now if we use the calculator, 180 minus 65 minus 25.8, we will find that angle C is equal to 89.2 degrees. And then we can use the sine trig again, or sine ratios again, saying now instead of A and B, we may use B and C. So sine B over B is equal to sine C over C. And now what do we have here for sine B is sine 65 over, I think it was 65, huh? Yeah, sine 65 over 25 is equal to sine 89.2 over C. And C is the unknown, is the X. Okay, so now cross multiply the two, so you will have C times sine 65 is equal to 25 times sine 89.2 degrees. Dividing both sides by sine 65, we will find that C is equal to 25 times sine 89.2 divided by sine 65. And C will be 27.8 0.6 meters. And this way we solved the triangle, meaning that we found all the sides and all the angles of this triangle, which is not a right angle triangle, but on this case, what we will use is sine ratios. The next law that we will use in trigonometry is that is known as the cosine law. Cosine law, again, is used when we have non-right angle triangle, and let's say is A, B, C. And even this formula is in your formula sheet. So C squared is equal to A squared plus B squared minus 2 times A times B times cosine A. And in the formula sheet, I think that you have even the formula for cosine. The formula sheet is posted on D2L. If you can just print it and have it for your own reference, that will be amazing. So now on this case, let's suppose that we are looking for side C when A is given as 43 meters and B is given as 25 meters, while the angle A is 120 degrees. So we will apply the formula straight. So angle or side C squared that we are looking for is equal to 43 squared plus 25 squared minus 2 times 43 times 25 times cosine of 120 degrees. And now using your calculator, C is given as 59.6 meters. And now in order to find angle C or angle B, you can use, let's say, sine law. So in this case, what we will have in terms of the sine law, or you can use even cosine, now that we know all the three sides. So sine of angle A over length of angle A is equal to sine of angle B over length of B. And sine of angle A is the same as saying sine of 120 over 43 is equal to sine of angle B over 25. From here, sine of angle B will be 25 times sine 120 over 43. So angle B will be, using your calculator, will be equals to 30.2 degrees. Now angle C is the sum of inside angles in a triangle is equal to 180 degrees. Do you have any questions?